Welcome to Web Handling. My name is Dave Roysum. I am super excited to begin a new series on edge effects. In this clip, we show that most internal rejects and customer complaint comes from the edges of the web. In this clip, we show how to find the economic amount of trim to take. In this clip, we show you why you are probably not taking enough trim. Finally, we show that physics may prevent you from fixing the edges. Studies across many industries have indicated that up to 80% of internal rejects and customer returns come from the two-end roles. That is one of the many reasons that the paper industries and a few others have introduced traceability into their role ID numbers. In this system, the front and the back roll cut from a parent roll are designated A and Z respectively. You can learn much more about traceability in my Web 401.21a through G series. So now we are confronted with what seems to be a true dilemma. If we increase the amount of trim, we increase the amount of money lost in trim. On the other hand, if we decrease the amount of trim, we increase the amount of internal rejects and customer returns, as shown in red in the graph of rejects and returns as a function of CD position. So how do we solve this dilemma? Those of you who follow my work would immediately know we need to find the economic optimum amount of trim to take. To begin is super easy. We merely plot the amount of trim cost versus the amount of trim taken. With no trim, we have no trim losses. And 100% trim, we have 100% trim losses. If we only focused on this easily seen trim cost, we might be inclined to minimize trim. However, as we will see shortly, that is not the economically optimum and correct answer. To get the complete and correct economic analysis, we must also tabulate the amount of internal rejects and customer complaints as a function of the amount of trim taken. While this might take a little bit more analysis work, the conclusion you will get will be something like this figure. That is, if you take no trim, the customer complaints would be high or even very high. However, even if you take a lot of trim, you will still get some complaints because the edge effects are not the only reason for quality troubles. The baselines of troubles not related to edge effects is shown by the dotted line. Now we are set to finish the optimization. We consider both trim costs and quality complaints versus the amount of trim taken. In other words, trim is not good or bad. Rather, it is good and bad at the same time. We then sum the goodness and badness of trim to get total costs. So now all we have to do to find the economic optimum amount of trim to take is to find the minima of the sum of the two cost curves. This is the amount of trim you should take, not minimum trim, and certainly not zero in most cases, as this will result in reduced profits due to increased quality complaints for the edges of the web. Now is a great time to show why you are probably not taking enough trim. That is because management easily sees trim costs, and thus they are relatively overvalued. On the other hand, the costs of quality complaints on the edges is not so easy to tabulate, and thus are undervalued. Thus, you are very likely not taking the economically optimum amount of trim from the edges of the web. We reach similar conclusions on maintenance, specifically roller repair in Web201.49a through D. Many, if not most plants, do less than the economic amount of maintenance on their machine for the same reasons as we discussed here. Maintenance costs are easy to see and thus are relatively overvalued by management. Of course, the possibly legitimate critique of this analysis would try to avoid the dilemma by giving a third choice, that is, fixing the edges of the web. While we absolutely for sure should see what we can do to fix the edges of the web, or at least improve the edges, we will run into at least two mitigating factors. The first is that machines are imperfect and that improving the edges will likely cost money, perhaps more than it saves in reducing quality complaints from the edges of the web. The second reason is even more daunting. That is, in many cases, edge effects are inevitable or all but guaranteed by the inviolate laws of physics. In the next clips, we will discuss these all but inevitable edge effects, such as biaxial stresses, air entrainment, temperature, thickness and bagginess, necking, and web breaks, and much, much more. Thank you so very much for joining me in this Edge Effects mini-series. Please join me next week where we will continue our discussion of edge quality challenges by talking about biaxial stresses. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.